Hello everyone, welcome to KNO Academy YouTube channel. In this class, we are going to discuss some of the important questions on the topic physics. So without wasting the time, let's start the session. The first and foremost question is, match list 1 with list 2 and select the correct answer from the codes given below. So here in list 1 you can see physical quantities, and in list 2 you can see units, the corresponding units. Okay. So the physical quantities are luminous intensity, work, temperature and distance. And under unit you can see meter, joule, Kelvin and candela. So here luminous intensity is measured in candela. So here it is option A. Okay, and work is measured in joule. It is option B. And temperature is measured in Kelvin. It is option C. And distance is measured in meter. That is option D. So candela, joule, Kelvin, meter. That is 4, 2, 3, 1. So option C is having 4, 2, 3, 1 as option, right? As answer. Hence, option C is the correct answer for this question. So here I have taken 7 quantities as length, mass, time, amount, temperature, electric current and luminous intensity. Here these 7 fundamental quantities are measured with international standard units, that is SI units. Okay, so length is measured, the SI unit of length is measured in meter, and SI unit of mass is kg, and time is measured in second. These are SI units. Okay, that is international standard units. And amount of substance is measured in mole, and the unit of temperature is Kelvin, and unit of electric current is ampere, and unit of luminous intensity is candela. Okay, this you should know. So now let's move on to the second question. So the second question is, the force acting on a unit area of a surface is called dash, and the options are hertz, tension, pressure, gravity. Here what is the sentence? F, that is force acting on a unit area, that is A, is what? Pressure. Okay, so P is equal to F divided by A. So the correct answer is option C. Pressure is the correct answer for this question. So here the force acting on a unit area of a surface is called as pressure. So pressure is defined as the force which acts perpendicular to the surface. That is, if it is a surface, means force is always acting on a surface at an angle 90 degree. So this is called as perpendicular to the surface, and so this is force which is equal to 90 degree, that is perpendicular to the surface, and divided by area over which that force is acting is called as pressure. Okay, and what is tension? So tension is the pulling or stretching force that is transmitted axially along an object such as string, rope, chain, rod and other objects. So this is called as tension. So tension is nothing but it is also a force. Okay. Then what is hertz? Hertz is the unit of frequency, right? So what is frequency? So frequency is the number of cycles per second is called as frequency, and the unit of frequency is defined by hertz. So next, last one is gravity. So what is gravity? It is the force that attracts a body towards the center of earth is called as gravity. Okay. So now let's move on to the next question. What is the unit of force? So force is measured by the unit Newton, correct? So Newton is the unit of force. So, and what is kilogram? So kilogram is the unit of mass. And what is diopter? So diopter is the unit of power of lens. And what is decibel? So decibel is the unit of sound. Sound is measured by decibel, right? And Newton is the unit of force. So next question. What is the unit of electric field strength? What is the unit of electric field strength? So if you know the formula of electric field strength, you can easily identify the unit. So electric field strength E is equal to what? F by Q. Okay. So in other words, E is equal to, this also can be written as V by D. So this is potential difference and this is distance. So E is equal to FQ. This is one formula, and also E is equal to V by D. This is another formula for electric field strength. So here, if you know this formula, you can determine the unit of this electric field strength. That is, so F is measured in Newton, right? And charge is measured in Coulomb. So here, Coulomb per Newton, option A is Coulomb per Newton, option B Newton per Coulomb, option C Henry per Coulomb, and option D joules per Coulomb. What is the correct answer for this question? That is unit of electric field strength. Yeah, so Newton per Coulomb, the option B is the correct answer for this question. See here, the formula to calculate electric field strength is given as E is equal to F divided by Q, where F is force, Q is charge, right? And in uniform, along uniform field of electric field strength is given by E is equal to V by D, where V is the potential difference, not velocity, okay? So V is considered as potential difference and D is the distance. So if you consider this, so potential difference is measured in volts per D is measured in meters. So volts per meter is the another unit of electric field strength. Okay. So next question. Light year is related to what? What do you mean by light year? Yeah. So light year is the distance that light travels in 1 year. 1 year means 365 days, right? So when a light ray travels in 365 days, the distance traveled by the light in 365 days is called as light year. So light year is related to option A energy, option B speed, option C distance, and option D intensity. So what is the correct answer for this question? So yeah, so the correct answer is option C distance. Light year is related to the distance. Okay. So 1 light year is equal to how much? 9.46 trillion kilometers per year. So this is 1 light year value. That means, so light can travel in 1 year of 9.46 trillion kilometers. That is by 9.46 trillion kilometers. So this much of distance can travel by the light in 1 year. Okay. So next question. What is the vernier caliper is used to measure? So vernier caliper is used to measure what? Option A sound, option B temperature, option C speed, and option D length. So what is vernier caliper? So a vernier caliper is, it is an instrument, okay? So it is an instrument, so that is primarily used to measure linear dimensions like length, width, thickness of the objects, as well as the internal and external diameters of cylindrical objects. For example, if you consider a pipe like this, you can measure the diameter of this pipe using this vernier caliper instrument. Okay, so here the correct answer is option D, length is the correct answer for this question. That is, vernier caliper can be used to measure length. So next question. Sound waves cannot pass through option A solid liquid mixture, option B an ideal gas, option C a liquid gas mixture, and option D a perfect vacuum. So here you should know one thing, that sound needs a medium. Okay, it always needs a medium to pass. If no medium means it cannot able to pass. Okay, so here option D is the correct answer for this question, because in vacuum there is no particles present. Okay, it is an empty space. Vacuum means empty space, no particles present. So it is fully dark region. Hence, sound waves cannot pass through a perfect vacuum. Okay. So sound waves require a material medium to travel, and that cannot pass through a vacuum. So what do you mean by vacuum? It is an area without any air, without any molecules, without any atoms. And since sound waves are mechanical waves, they need a material medium of particles like air, water, or solids to vibrate and propagate. Okay, so you should know sound waves always needs a material medium like air, water, or solids. So in vacuum, sound waves cannot able to pass through it. Next question. The mirror used in automobiles to see the rear field of view is option A concave, option B convex, option C plane, and option D none of these. See, in automobiles to see the rear field of view, we use convex mirror. Okay, so option B is the correct answer. That is, the mirror used in automobiles to see the rear field of view is a convex mirror. Convex mirrors provide a wider field of view, allowing drivers to see more amount of traffic behind them compared to plane or concave mirrors. So option B, convex mirror, is the correct option. So for extra information, I have given the uses of convex mirror here. So here convex mirror uses are like this. It is used as a rear view mirror in automobiles. It is used in ATMs for security purposes. When convex mirrors are utilized, object magnification becomes simple. Okay, to magnify objects we use convex mirrors. So it's found in sunglasses, and it is also used as a reflector for street lights. So this is the applications of convex mirror. So next, uses of concave mirror. So concave mirrors are versatile optical tools used for various purposes like magnifying objects, focusing light, creating magnified images, and they are commonly found in applications like headlights, telescopes, shaving mirrors, and solar furnaces. Now let's see the plane mirror uses. So plane mirror uses are like this. So the plane mirrors are mostly used in telescopes, microscopes, solar cookers, periscopes, kaleidoscopes, lasers, torchlights, optical instruments, looking mirrors. Okay, it is also called as grooming mirrors. Okay, and then safety and security purposes, decorative and architectural applications. These are the applications of plane mirror. So now let's move on to the next question, that is, The kinetic energy possessed by an object of mass m and moving with a uniform velocity is. So here the question is asked about the formula to calculate kinetic energy, and the options are like this. Option A half mv square, option B mv, option C mv square, and option D 1 by 4 mv square. So note kinetic energy. What is kinetic energy? So it is the energy possessed by an object by virtue of its motion. Why motion? Because kinetic itself represents what? Motion, moving body. Okay. So hence it is the energy possessed by an object or by a body by virtue of its motion is called as kinetic energy, and the formula is given by half mv square. Okay. And what is potential energy? It is complementary to kinetic energy, that is energy possessed by the body by virtue of its position is called as potential energy, and the formula for potential energy is given as mgh, where m is the mass, g is the acceleration due to gravity, and h is height of an object. Okay, so example for kinetic energy is moving chair. Okay, so moving any object or lifting any object is considered to be as the examples for kinetic energy. And for potential energy, storing water in a tank or water collected in dam. So these are the examples for potential energy. Understood? So kinetic energy is given by half mv square. So next question. The number of oscillations or vibrations per second is called the dash of oscillation. That is, the number of oscillations or vibrations per second is called the dash of oscillation. And the options are like this: phase, amplitude, frequency, wavelength. So what is the answer for this question? Yes. So the correct answer is frequency. Frequency, what is frequency? The number of oscillations per second is called as frequency, and it is measured by a unit called hertz, right? So these four are the characteristics of a wave. Okay, that means wave characteristics are nothing but phase, amplitude, frequency, wavelength. These are the characteristics of a wave. Okay, so here if you look into this image, here a wave is given. So it is a combination of crest and trough. Okay, so what is crest? It is the uphill. So it looks like hill, right? This one. So this looks like a hill. So this is called as crest, and the downhill, this one is called as trough. Okay. So the middle line is called as equilibrium line or equilibrium position. Okay. So these are the characteristics of a wave. So the number of oscillations or vibrations per second is called as frequency of oscillation. So here option C, frequency, is the correct answer, and frequency is measured in hertz. Okay. So what is phase then? So phase refers to a specific point or specific position within a cycle of a wave or oscillating system. So it is measured from the reference point. So reference point is nothing but the equilibrium line is called as the reference point. Okay, this is called as phase. And what is amplitude? So this is called as amplitude. It is a maximum distance from the mean position or equilibrium position is called as amplitude. Okay, and what is wavelength? So it is the distance between any two successive crest or any two successive trough is called as wavelength. Understood? So next question. Which conventions are followed for spherical mirror and lens? And the options are new Huygens sign, new Cartesian sign, new Einstein sign, and new Newton sign. And the correct answer is new Cartesian sign. So here, to describe the position or height of the image produced by the object using lens or mirrors are used by are measured by using Cartesian sign coordinates. Okay, see here. So for both spherical mirrors and lenses, either convex or concave, okay, the new Cartesian sign convention is generally used to define the signs of distances and heights related to the image formation by the object. So object is placed here. So in front of the object, convex or concave mirror is placed and the corresponding image will be formed. So in convex mirror, image is formed in front of the lens. So in concave mirror, behind the lens, image is formed like this. Okay. So the image position, the corresponding image produced by the object like this, okay, using a concave or convex lens are measured. The position, the height, okay, the distance are measured by using new Cartesian sign convention. Understood? So here Cartesian sign convention has focal length, focal points and optic center. So the middle one, so this is called optic center. O represents optic center. And these F1 and 2 F1, they are called focal points. Focal points of the corresponding lenses or mirrors. Okay. So the position or the distance or the heights of the image formed by the object by using lenses or mirrors are defined by using new Cartesian sign convention. Okay. So next question. Power of lens of focal length f is given by the formula P is equal to 1 by f, P is equal to f by u, P is equal to u by f and P is equal to v by u. Here the correct answer is P is equal to 1 by f. See, power of lens is denoted by capital letter P and that is equal to 1 divided by f. Okay. So here f, what is f? F is focal length and focal length measured in meter. Okay. So P is equal to 1 by f, that is power of length is inversely proportional to the focal length of the lens. Okay. And what is the unit of power of lens? It is meter power minus 1. Since f is in denominator, therefore P is equal to 1 by f, this is equal to 1 by m. If you take this m to the numerator, it becomes minus 1. So unit of power of lens is per meter or meter power minus. Okay. So the power of lens denoted by capital P is the reciprocal of its focal length f with the focal length measured in meters. Okay, focal length measured in meters. This relationship is expressed as P is equal to 1 by f and the unit of power is the diopter. So diopter is nothing but per meter, where 1 diopter is the power of lens with focal length of 1 meter. Okay, next question. Metals produce ringing sounds. They are said to be lustrous, ductile, sonorous and malleable. So here the correct answer is option C, sonorous. So here the option itself shows the answer, right? Sonorous means sound. So whenever metal produces ringing sounds means it is called as sonorous. Okay. And what do you mean by lustrous? ductile, malleable? C. A substance is said to be sonorous if it is capable of producing sound, and the metals that produce sound on striking a hard surface is called as sonorous metals. And what do you mean by lustrous? So, lustrous is a physical property of a metal that shows shining nature. Okay, the shiny property of a metal is called as lustrous. And what do you mean by ductile? Ductile is the property of the metal that can be able to drawn out into thin wire is called as ductile. And what is malleable? So malleable is also another property of the metal and that can be able to hammer or pressed into shape without breaking or cracking is called as malleable. Okay. Now let's move on to the next question. So change in the velocity of an object per unit time is called dash. And the options are angular velocity, acceleration, displacement, and angular displacement. What do you mean by change in the velocity? That is v by t is called as acceleration. What is d by t? That is displacement by time taken is called as velocity. Okay, this you should know. And what is angular velocity? So angular velocity is the rate of change of angular displacement, that is d omega by dt. See here, angular usually represented by w omega. Okay, so the correct answer is acceleration. Option B, acceleration. So the change in the velocity of an object per unit time is called acceleration. So what is angular velocity? It is the angular velocity of a particle is the rate of change of angular displacement. And what is displacement? So it is the change in position of an object. And what is angular displacement? So it is an angle through which the body rotates around a center or axis of rotation. It is called as angular displacement. So next question. What is defined as rate of doing work or the rate of transfer of energy? The options are like this. Option A, force. Option B, power. Option C, speed. And option D, work. So the rate of doing work or the rate of transfer of energy is always called as power. Okay. So power is measured in watts. Okay, that is capital W, which is equivalent to 1 joule per second. Okay. In other words, power is the amount of energy used or transferred per unit time is called as power. So P is equal to W by E. Okay. So next, what is force? So force is simply the pushing or pulling on an object that resulting to the interaction between the two objects is called as force. It is a pushing or pulling on an object and that can change the position of an object is called as force. And what is speed? Speed is the distance traveled by an object per unit time is called as speed. And what is work? So work is the energy transferred to or from an object through the application of force along a displacement is called as work. So next question. The force of attraction of earth on an object is known as dash. Option A, mass of object. Option B, weight of object. Option C, motion of object. And option D, friction of object. So here, the force of attraction of earth on an object is called weight of an object. So whenever a force is acting on any object means, so this is nothing but weight of an object. Okay, na? This is termed as weight of an object. So W is equal to mg. So what is m? It is mass of an object. And what is g? So g is acceleration due to gravity. And the value of g is 9.8 meter per second square. So this is the value of g. This is acceleration due to gravity. Okay, and the force of attraction of earth on an object is called as weight of an object. And what is mass of an object? So mass is nothing but, if you consider any object, so the number of particles or the atoms present in that object is called as mass. The amount of particles or the amount of atoms in an object is called as mass of an object. And what is motion of an object? So motion is nothing but changing in the position of an object is called motion of an object. Okay, and what is friction of object? Friction is nothing but what? It is opposition offered by an object is called friction. That means rubbing of two surfaces. Okay, rubbing of two surfaces against each other is called as friction. Okay, and the force acting on this process friction is called frictional force. Understood? So now let's move on to the next question. What is defined as the product of mass and velocity? The product of mass and velocity is what? So option A direction, option B momentum, option C magnitude, and option D displacement. So the product of mass and velocity is termed as momentum, that is represented by small p. So P is equal to mv. Product of mass and velocity is called as momentum. Okay. And momentum is a vector quantity, because so here vector velocity always vector quantity, right? And mass is scalar quantity. So multiplication of vector and scalar is gives vector. Hence momentum is a vector quantity. So and that describes the amount of motion of an object possesses. And it's calculated using the formula momentum P is equal to mass into velocity, that is mv. Next question. Pressure is a dash quantity, and the options are scalar, vector, base, space. So pressure is a scalar quantity because pressure has only magnitude but not direction. Hence it is termed as scalar quantity. Okay. And pressure is defined as the ratio of force to unit area, and both the force and area are vector quantities. Correct? P is equal to F by A. So force is vector quantity, and again area is also vector quantity. So vector cancels, no direction, only it has magnitude. That's why pressure is a scalar quantity. Okay, it has magnitude but no direction. So here I am showing some of the quantities which are scalar and vector. Okay, so scalar quantities are like temperature, mass, time, length, area, etc. So these are scalar quantities. I have taken some examples on scalar, and also examples for vector quantities are like displacement, vector, acceleration, force, momentum, etc. So scalar means, so the quantities which have only magnitude but no direction is called as scalar quantity. Okay, and what is vector quantities? The quantities which have both magnitude and direction. So such type of quantities are called as vector quantities. So for your extra information, I have provided some quantities which are scalar and which are vector. Okay, this you can take a screenshot. So next question. What is the relation between power voltage and resistance R, that is PVR. See, and the options are like this: P is equal to V square by R, P is equal to V by R, P is equal to V by R square, and P is equal to VR square. See, by using Ohm's law, what is Ohm's law? P is equal to IR, or I is equal to V by R. Anything you can take. So if you, and what is power? P is equal to VI, correct? So here P is equal to, substitute the value of V here, okay? So V is equal to what? I R into I is equal to what? I square R. Or simply I can be written as what? V by R, correct? So substitute I value. So I is what? V by R. It is square, it is I square. So make it as square. V by R square into R is equal to V square divided by R square into R, right? Because it is square. So 1 R get cancelled. So V square by R. So the relation for pressure can be given as V square by R. So hence the option A, P is equal to V square by R, is the correct answer for this question. Okay. Next question. What will happen when ship enters a river from sea? Option A, it sinks a little. Option B, it rises a little. Option C, its level remains the same. Option D, depends on the material of which ship is made. See, if you compare sea and river, so amount of molecules in sea more, correct? So compared to sea, river is less. That means amount of molecules, water molecules. So density, if you look into the density of sea and river, so what is density? It is the mass by volume, correct? So mass is nothing but amount of particles or amount of molecules, indicates what? Mass. Okay, see here, density is directly proportional to amount of particles in the sea and also in river. So compared to sea, density is more than river, correct? Hence, whenever a ship enters into a river from sea, it sinks a little because of low density of river. Okay, so the correct answer is option A, it sinks a little. So look into the answer here. When a ship enters a river from the sea, it will sink slightly lower in the water. So this is because the density of sea water is higher than the density of river water. Hence, a ship's buoyancy, which determines how high it floats, okay, so is directly related to the density of the surrounding water. It mainly depends on the density of water molecules, okay, and also buoyancy. So buoyancy is nothing but upward force exerted by water is called as buoyancy. Okay, so the correct answer is option A, it sinks a little because of density of the water molecules of the sea water compared to river water. Okay, so next question. What is the frequency range of ultrasound? Option A, between 20 Hz to 20 kHz. Between 200 Hz to 2000 Hz. Below 20 Hz and above 20 kilohertz. See, human can hear the frequency range between 20 to 20 kilohertz. Okay, so this is the frequency range that human can hear the sound, and the sound can be divided into two types. One is ultrasound and another one is infrasound. Infra and ultra. See, what is ultra? It is the frequency range which is above 20 kilohertz is called as ultra. So above 20 kilohertz. Kilo means 1000, okay, or 20,000 hertz you can say. And infra means below 20 hertz is called as infrasound. And here, what is the question asked? What is the frequency range of ultrasound? It is about 20 kilohertz. So option D is the correct answer. So audible sound, humans can typically hear sounds with frequencies between 20 to 20,000 kilohertz, 20,000 hertz or 20 kilohertz. Okay. And infrasonic sound, the sounds with frequencies below 20 hertz are considered to be as infrasonic. Okay. And ultrasonic means sounds with frequencies above 20,000 hertz or 20 kilohertz are called ultrasonic waves or ultrasound. Next question. A coin in a glass of water is appeared to be raised is due to dash. Option A, reflection of light. Option B, refraction of light. Option C, total internal reflection. And option D, total internal refraction. So the correct answer for this question is refraction of light. Okay. So whenever you place a coin inside a glass of water means it appeared to be as raised, that is due to refraction of light. What do you mean by refraction? So, if you consider a two medium, that is air and glass, okay? So here a glass of water. Here I have placed a coin. If you look into this glass of water, this coin is appeared to be as raised here, somewhere like this, okay? So this is due to refraction of light. Okay, what is refraction means? If you consider two medium, air and glass medium, okay, so I have taken a normal here. Normal means perpendicular to this surface, that is glass surface. So when a light ray is incident on this glass surface, it bends towards the normal like this. So this is normal. So like this is incident ray. Okay, when light ray enters into a glass medium, that is from air to glass medium or rarer medium into denser medium, the light bends towards the normal. It's called as refraction. Okay, so that is bending of light towards the normal whenever it passes from rarer medium into the denser medium is called as refraction of light. So due to this mechanism, the coin in a glass of water is appeared to be as raised. Okay, na? So next question. Optical fiber works on the principle of dash. And the options are polarization, total internal reflection, total internal refraction, and scattering of light. See, what is optical fiber? This is the optical fiber, okay? So, see, in this optical fiber, light is reflecting again and again, repeated reflection of light inside the optical fiber is called as total internal reflection. Total internal reflection. By using this principle, optical fiber works. Okay. So, to happen total internal reflection, two conditions must be followed. One is a ray of light must pass from or must travel from denser medium into rarer medium, and the angle should be greater than the critical angle. These two conditions must be satisfied to happen total internal reflection. Okay. So this is not needed actually. For extra information, I am telling this. Okay. So optical fiber works on the principle of total internal reflection. Option B is the correct answer. Okay. So next question. The sky is appeared blue is due to polarization, scattering of light, reflection of light, and interference. So the correct answer is option B, scattering of light. So the sky appears blue is due to the scattering of light. So this phenomenon describes how sunlight is scattered by the tiny particles in the atmosphere. So whenever the sun rays enters into Earth atmosphere, okay, the shorter, see, sunlight is a composition of 7 colors, right? Vibgayar. So it is a combination of 7 colors, and here the shorter wavelength radiation, that is blue. So blue rays will be scattered more compared to the longer wavelength, that is red. Okay. So and also you can say why can't violet, why can't indigo? Because human eyes is sensible for blue rays compared to violet and indigo. That's why the sky is appeared blue in color. And this phenomenon is called as ray scattering, that is scattering of light ray by the tiny particles present in the atmosphere. Okay, so due to this scattering of light by the molecules present in the atmosphere or particles present in the atmosphere, so those particles will scatter more a shorter wavelength radiation, that is blue radiation, than the longer wavelength, that is red radiation. So this phenomenon is called as ray scattering. Okay, ray scattering is the type of scattering where shorter wavelength, that is blue, are scattered more strongly than longer wavelength, that is red. Okay, and uh, violet and indigo are not sensible to human eye. So that's why for human, skies appeared as blue in color. Understood? So this is due to scattering of light. So option B is the correct answer. So next question. The packets of light energy are called dash. The options are like this: protons, electrons, photons, and neutrons. So the correct answer is option C. Photons is the correct answer. So photons is nothing but it is a tiny packets of energy. Small packets of light energy is called as photons, and photons have zero mass and zero charge. Okay, charge is zero, mass is zero for photon. So it is a fundamental unit of light and all other forms of electromagnetic radiation. Okay, so next question. Diamonds shine due to the phenomenon called dash, and the options are like interference, total internal reflection, diffusion, and diffraction. So the correct answer is total internal reflection is the correct answer for this question. So diamonds appear to shine due to the phenomenon of total internal reflection. So this occurs when light travels from denser medium to less dense medium, that is rarer medium. Okay, at an angle greater than the critical angle, causing it to reflect back into the denser medium instead of refracting out. So if you consider a diamond, okay, see here light is traveling from glass to air medium. So this is glass, right? Diamond is made up of glass, somewhat glass. See here, so light is uh, traveling from denser medium to rarer medium means it is not going out. It is whenever light is going from glass to air medium means, so in the phenomenon of total internal reflection, it will not completely go. It again bounce back into the same medium, that is glass medium only. That's why it appeared as shining. Okay. So, and here the phenomenon that is taking place to shine the diamond is due to total internal reflection. Okay. So, here I have said the condition in previous question, that is the angle must be greater than the critical angle and the light ray must pass from glass to air, that is high denser medium to low denser or less denser, that is glass to air. If these two conditions followed means total internal reflection taking place. If total TIR is there means obviously diamonds shine. Okay. Next question. The liquid drops or gas bubbles are always in spherical shape is due to dash. So option A, volume tension, option B, surface tension, option C, gravitational force, and option D, magnetic force. So the correct answer is surface tension. Option B is the correct answer. So liquid drops and gas bubbles are always spherical in shape is due to surface tension. Okay. So surface tension is nothing but it is a tendency of a liquid surface. It is a tendency of the liquid surface to contract or to minimize its area, which results into a spherical shape. Okay, that is smaller area, smallest surface area. This phenomenon is called as surface tension. So next question. Escape velocity of a rocket fired from the earth towards the moon is a velocity to get rid of the dash. So option A, Earth's gravitational pull, option B, moon's gravitational pull, option C, centripetal force due to the earth's rotation, and option D, pressure of the atmosphere. See, if any object, if it is coming out of the earth means it has to overcome from the gravitational pull, that is earth's gravitational pull, then only it can come out of it, that is come out of the earth. Okay, so the correct answer is earth's gravitational pull. So the escape velocity of a rocket fired from earth towards the moon is the minimum speed that is required to overcome earth's gravitational pull and escape its influence, allowing the rocket to travel beyond the Earth-Moon system. So this escape velocity is necessary to ensure the rocket that doesn't get pulled back by Earth's gravity after reaching the moon. Okay. So next question. The force which acts towards the center is known as dash. And the options are like this. Option A, centripetal force. Option B, centrifugal force. Option C, magnetic force. And option D, nuclear force. And the correct answer is option A, centripetal force. What do you mean by centripetal force? If any object that is moving in a circular motion, so this is center. Okay, if an object is moving in a circular path, okay, so the force which is acts on this object is always towards the center. It is always acting towards the center. So this is called as centripetal force. What is centripetal force? The force which acts towards the center is called as centripetal force. And what is centrifugal force? It is away from the center. Away from the center like this. So this force is called as centrifugal force. Okay. The force which acts away from the center along a circular path or circular motion is called as centrifugal force. And what is magnetic force? It is the force of attraction or repulsion between the two poles, that is north and south pole, is called as magnetic force. And what is nuclear force? It is a force between the protons and neutrons inside the nucleus is called as nuclear force. Okay. So when a body moves on a circular path, the force that acts on the revolving body towards the center is called as centripetal force. So answer is centripetal force for this question. And the centrifugal force is a force that acts on a body in a direction away from the center. Okay. And magnetic force can be defined as the attractive or repulsive force that is exerted between the two poles of a magnet and electrically charged moving particles. Is called as magnetic force. And nuclear force is defined as the force which exists between the protons and neutrons present in the nucleus to keep them bounding together. Is called as nuclear. Now let's move on the next question. When a bottle of perfume is opened in one corner of a room, the smell spreads throughout the room. This is an example of dash. And the options are surface tension, capillarity, viscosity, and diffusion. So the answer is diffusion. What do you mean by diffusion? It is a movement of molecules from higher concentration to lower concentration. Okay, higher concentration to lower concentration is called as diffusion. So by this process, the perfume is spreading throughout the room. So the spreading of perfume smell throughout the room when a bottle is opened is an example of diffusion. And diffusion is a process where molecules of a substance move from an area of high concentration to an area of low concentration. Next question. When ice just melts, option A, there is no change in volume. Option B, there is no change in temperature. Option C, there is no change in state. And option D, none of the above. See here. So when ice just melting means obviously the volume changing, right? If it is a cube means when temperature is applying on this cube means it is gradually turning out to liquid. That is volume is changing. This is wrong. And there is no change in state. State is changing, right? From the state of solid to liquid. State is changing. This is also wrong. And none of the above. There is no change in temperature. This is right. How means if you consider ice. Okay. See here. So the atoms in the ice are tightly bounded together. So when temperature or heat is applying means, so from the heat, the temperature is simply breaking up these bounded molecules into water. Okay, since the heat supplying on the cube are just 2 break just to break up the molecule, that is water molecule, into water, or atoms into water. Okay, and there is no change in the temperature of this ice. So temperature is just applying to break up the bond between the molecules, and here no change in temperature in the ice cube. Okay, so when ice is melting means its temperature remains constant. There is no change in the temperature until all the ice has converted to water. Okay, this is because heat energy is absorbed by the ice to break the bonds between the water molecules. Okay, so preventing the temperature from rising. So just to breaking up the bonds, this heat energy is absorbing by the ice just to break up the bonds, and by during this the temperature is not rising. Okay, so the temperature remains constant only the phase is changing, that is from solid to liquid. So the temperature will only increase after all the ice has melted to water. Understood? So next question. Change occur when a light ray enters from air to glass. Option A, increase wavelength. Option B, decrease wavelength. Option C, increase wave force. And option D, no change wave. C. So change occur when a light ray enters from air to glass. So this is glass. This is air. So this is normal. Okay, this is normal. When a light ray, this is normal. Normal. Air, glass. Okay. When light ray is entering from air to glass means it bent towards the normal. Okay. So whenever it is bending means there is a change in wavelength. Change in wavelength. That is decrease in wavelength. Okay. So wavelength is also decreasing and also speed. But frequency remains constant. Okay. So here decrease wavelength is the correct answer. See, when a light ray enters from air to glass, see here the first figure, air to glass, several changes occur due to the phenomenon of refraction. Refraction means what? Bending of light towards the normal when light ray enters from air to water. Okay, and its speed and wavelength decreases and the frequency of the light remains unchanged, it means constant. So there is a decrease in wavelength and also speed when light ray enters from air to water. Okay, or air to glass, any other medium you can take here. So air to water or air to glass. So during this process or during refraction, wavelength and speed of the light ray decreases and frequency remains the same. See here in second picture, the light ray is going from water to air means this light ray is going away from the normal. This is normal. Okay, it is going away from the normal. So next one, which of these gases in our atmosphere absorb the harmful UV rays from the sun? And the options are methane, neon, helium, ozone. So the correct answer is ozone. In yesterday class only we have discussed that is the ozone. Ozone is a 3 atoms of oxygen, right? So O3 is called as ozone. So this ozone layer is surrounded by the earth, surrounding the earth. Okay. So earth is surrounded by ozone layer, that is O3 layer, and this O3 layer is protecting us from the harmful UV radiation that is coming from the sun. Okay. So the gas in our atmosphere that absorbs harmful UV rays from the sun is ozone. So ozone is referred to as O3, is a molecule found in stratosphere layer of the Earth's atmosphere that is specifically designed to absorb the majority of the sun's harmful ultraviolet radiation, that is protecting the several life on the earth. So next question, which petroleum fraction is used as fuel in jet aircraft? And the options are CNG, petrol, kerosene and diesel. So the correct answer is kerosene. So kerosene is used as a petroleum fraction in jet aircraft. So it's a refined light petroleum product often referred to as Jet A1 or JP8 in aviation context. Okay. So next question. Which device among the following is the most energy efficient device? So nowadays you can see everywhere LEDs are using rather incandescent bulbs, CFL and tube lights, right? Because the high energy efficiency high energy due to the high energy efficiency, LEDs are most often are using in households, decoration purposes everywhere. Okay. So LED bulbs are generally considered the most energy efficient lighting device currently available, so compared to other common lighting options like incandescent bulbs, CFLs, and even some older LED models. LEDs use significantly less energy to produce the same amount of light. Okay, so they also have a much longer lifespan, further increasing their energy efficiency over time. So the last question, study of planets, solar systems, galaxies, etc. is known as astrophysics. Okay, so it is the study of astronomical bodies, namely the planet, solar system, galaxies, etc. It deals with the physics involved in motion, formation and other phenomena related to astronomical bodies. So the correct answer is astrophysics. So here I am giving some assignment questions. So the first question is, the force which is away from the center is called, already we have discussed, right? It is centrifugal force. Centrifugal force. So second question, who proposed heliocentric planetary motion? Please take the assignment questions. And the third one is, what is the mass energy equation given by Einstein? And fourth question is, the neutron has dash charge. Okay. Please answer for these questions in the comment section. Okay. Thank you.